is a vector? This is a directed line segment. This one is a vector quantity. Why directed? Because it has direction from O to A. And where do you put the arrow? At the tail or at the tip? Don't put the arrow at the tail of the vector. You put it at the tip of the vector or any point in between. So in this diagram, OA is a vector, which we could have also represented this manner by putting arrow at the end. This is also a vector. So this OA equal to A is a vector over there. What is the magnitude of the vector? Magnitude of the vector OA is, we write this manner, or mod A. This is actually, this is equal to length of the vector, which is the straight line distance between the tail. This one is the tail and this is the tip. So length of the vector is magnitude. There is another name that is called modulus of the vector. Modulus of vector A. So it is straight line distance between the tail and the tip. If it is a scalar quantity, you need to write only 5 kg of rice, you just write. But vector, it has direction, magnitude, both. Like velocity is a vector quantity. It is directed in a particular direction. Acceleration is a vector quantity, idea you already have. So here, vector we represent diagrammatically by assigning a tail, a tip and a arrow. And length of the vector is the straight line distance between the tail and the tip. Different types of vectors are there. Vectors may be parallel vectors. What are those? This is a vector, this is another vector. By mistake, if you put arrow anywhere, it doesn't matter. Just don't put at the tail. So these two vectors, A and B, are parallel. Why? They do have the same direction, they are parallel vector. So two vectors are said to be parallel if they have same direction. And then two vectors may lie on the same line. Then it is said to be collinear vectors. What are those? On the same line, we are representing two vectors. O to A is one vector, then O to B or A to B, they are also vector lying on the same line. So in this diagram, in the diagram OA, AB and OB are three collinear vectors. So for collinear vectors, they have the same direction as well as they lie on the same line. You need to know one very important or remember one very important property of vector, that very important property will be what? That a vector can be slid parallel to itself. Okay? So just tell me from this definition the vector A and A and B, they are parallel, no? Because they have same direction. If I say that they are collinear also, then also we are right. Why? Because this vector we can take on the vector B, because they are parallel. We can slid the vector. B we can take on A, or A we can take on B. So, collinearity and parallelism, basically there is no difference when you are treating vector quantities. Vector can be slid parallel to itself. That's why parallelism means collinearity. Never forget that. Okay? Now, vectors may be co-initial. What are co-initial vectors? If two or more vectors are starting from the same origin, O to A and O to B, starting from the same point, so they are co-initial vector. If you take another one, that vector OC, there also, this is also co-initial. A, B and C are co-initial vectors. Vectors may be co-planar. Why? I am telling you. Co-planar vectors. If two or more vectors lie on the same plane, then they are coplanar. So in this plane of paper, these two vectors are coplanar. Suppose this one is R vector, S vector, they lie on the plane of this paper or board, so they are coplanar vectors. And one thing you should remember, that any linear combination, of R and S, that is say X into R plus Y into S, where X, Y are scalars, are also coplanar. So R and S are coplanar. X into R plus Y into S also coplanar. They lie on the same plane. Okay? So three vectors, A, B, 2A, 3B, even 2A plus 3B, 3A minus 4B, they are also coplanar. They lie on the same plane. Okay? So, hope you understand the concept of coplanar vectors also. Now we can define like and unlike vectors. What are those? Two or more vectors alike if they have same direction. Unlike vector means what? They don't have same direction. So these two vectors A and B, they have same direction, they are like vectors. Unlike vectors, have different directions. Next we are going to learn that zero vector. What is it? Magnitude of a vector may be anything. It may be 0 also, maybe 1 also. If it is 0, then we cannot represent. So 0 vector, mathematically we will write this manner. Just this one is a 0 vector. It has no magnitude. Okay? It has, we write a direction over there because when we learn addition of two vectors, then 0 vector is a topic over there. Sometimes we need to get a 0 vector. We need to add a 0 vector. That's why concept you know that it has direction along the direction of a given vector, but its magnitude is 0. We'll be writing, just putting arrow above the 0 sign. Then we are going to define localized and non-localized vectors. Localized, you can say free, localized and free vector. From the statement only, I mean from these two words only, it is clear what are going to be localized. A vector is given. If you draw a vector here at this point A and it is parallel to this vector, they are parallel. Then this vector, say I am taking AB, is a localized vector. Why? It is localized because we have a fixed point in the space and we have drawn parallel to a given vector. That's why AB is a localized vector. If it is free, so for a localized vector, a point on it is fixed in the space and it is parallel to a given vector. If a vector is not localized, no fixed position and not drawn parallel to a vector, then it is free vector. Clear? So localized and free vector you understand. Now we learn addition of two vectors. if you want to add two vectors, you have to take the help of triangle law. These are two vectors. We have to say two free vectors are there, A and B. You want to add these two vectors. So they are free vectors. They can be moved anywhere, position is not fixed. If you want to add these two vectors, then you need to take the help of triangle law of addition of two vectors. Triangle law of addition of two vectors. What you are going to do, let me tell you. This vector A is there. What you will do, this vector B, you start moving parallel to itself. Take it here. Okay? And this one also. So to add two vectors, you take vector as A and B. The second vector, you have seen that we have started from tip of the first one. This is A, this is B. They form the sides of triangle. These two vectors B, AB and BC. By triangle law, this will be the sum of two vectors A and B. Okay? This law is applicable in most of the vector operations. Like physics, what we have learned, those who are physics students here, parallelogram law, polygon rule. But you must remember that those are application of triangle law only. So triangle law is the basic. If you learn triangle law, then everything is done. So if you want to add two vectors A and B, then you take two vectors along two sides of triangle. Third side taken in opposite order will represent the sum of the two vectors. What we say, this is the resultant of two vectors. Okay, this is triangle law. So when you are adding two vectors, this we have taken A and this one B. Then, so far we have not defined negative of a vector. That also can be defined. Negative of a vector is what? This is vector A, this one B. You take the same vector B, but sense is opposite. Equal magnitude. The magnitude of B and magnitude of this vector is the same. We refer this one as minus B. Then this is A, this is minus B. Third side taken in opposite order will represent A minus B. Hope you have understood. So addition done by triangle law, subtraction also done by triangle law. So this side will represent the difference of two vectors. If this one A, B is opposite, equal magnitude minus B, then third side is A minus B. Okay? Now, a very important concept we learn here, that this addition is commutative, but subtraction is not commutative. See how? Vector addition is commutative. So for the concept we have learned, I am going to apply here. Vector addition is commutative. How will you prove it? What we will do here, we take this vector as A and this one as B. Okay? Then you know by triangle law this one represents A plus B. This is A plus B. Now we draw vectors parallel to A and B. First we draw a vector parallel to B. From where? From this point. This is OAB. Now we draw two vectors which are parallel to A and B. From here first B. Okay? These two vectors are parallel. They are equal. They lie also. So if this one B, this is going to be B. This one A, this is going to be A. Okay? Since this one A, this is A. Now, A plus B, you have taken this manner, A vector. I mean, OB represents A plus B. See, this time, B plus A is what? This is OA dashed. So, B plus A by triangle law is also OB. But OB what you have got? A plus B. Therefore, addition of two vectors is commutative. Obey commutative law. Commutative. Addition of two vectors is commutative. But subtraction, no. Subtraction never. In this diagram only. See, this one AB minus A, we just take A vector from here and draw in opposite sides. If this one A, then take a vector parallel to A. This one also represents A vector. So, this is going to be minus A. This is B and this is minus A. So, this one will represent B minus A. Okay? This one will represent B minus A. See, this one A minus B, here you got B minus A. It seems that even by using a little bit class 9-10 level geometry, you can prove that their magnitudes are equal, but they are not equal vectors. Why? Because A minus B are given this direction, B minus C in the other direction. So, subtraction of two vectors not commutative. Addition of two vectors is commutative, but subtraction is not. Now we are going to define the multiplication of a vector. What is multiplication of vector? In this class, we will be learning scalar multiplication. Scalar multiplication, what is that? You have taken this one vector A. Suppose it has magnitude 3 unit. You take a vector this manner. This is 1, 2, 3, 4, 5, 6. How do you write this vector? If this is A, this will be 2A. How to write 2/3 A? 2/3 A will be in the same direction, but magnitude will be of 2 unit only. Till this. this is going to be 2/3 A. 2/3 of that. Because we have taken just 1 unit and 2 units. Bit smaller, okay. 2/3 A. What about minus A vector? If this is A, say you want to write minus 2A vector. How to write? Minus 2A will be just opposite. Same magnitude, just opposite. This will be minus 2A vector. So, scalar multiplication, let A be a vector M into A represent a vector parallel to A or along A, and its magnitude is M times the magnitude of M times the magnitude of vector A. Okay, so you understand, A vector is there, MA is a vector, MA is a vector which is along the direction of A, and magnitude is M times that of vector A. Clear? Scalar multiplication, you understand. Now, unit vector. What is that? You draw a vector. You are taking a vector of magnitude 1, 2, 3, 4, 5 unit. AB vector, mod A or magnitude of A equal to 5. So I have represented that by taking 5 units. So this is representing 5A vector. No, this is representing A vector. What about A by 5? Magnitude of A by 5 is what? Mod A by 5 is what? This is mod A by 5, 1 unit. So if you want to draw A by 5 vector, it will be of 1 unit only. We will be writing A cap equal to A by 5. A cap or A hat, whatever you say. So we define it now. It may be of 10 units, then A by 10 will represent unit vector. Therefore, unit vector along the direction of a vector A is given by A cap equal to A by mod A. Okay? And its magnitude, I have told you, that magnitude will be of 1 unit. Mod A cap always 1 unit. So far you have understood what is triangle law, what is magnitude of vector, what is unit vector along the direction of given vector. Now, if I tell you, can you draw a vector of magnitude, say any magnitude, 9, 10, 15, whatever, along the direction of given vector? Then you need to take the help of unit vector. Okay? So I am writing the most important use of unit vector. A cap helps to write a vector B of magnitude magnitude m along the direction of a given vector. A cap helps to write a vector b of magnitude m. M is any. How to? Of a given vector we are taking A. So how to represent the vector b? A vector is given. So you take the vector A first. You draw it. This is A. Then you draw a cap. Then you multiply this by m. M may be anything. So this we have magnified m times this way, m times. Then b is going to be m into a cap. So a vector of given magnitude is there, you can draw a vector of any magnitude in the direction of that vector. Now, this concept of unit vector and the triangle law will help you to represent a vector in 2D. Okay? So how to represent a vector in 2D? Representation of a vector in 2D. How to? This one is a vector in 2 dimensions. Well-defined vector. All vectors are well defined. They have fixed direction and magnitude. So, OA equal to R is a given vector. We want to represent R in 2D. How to? What we will do there, you draw a coordinate axis through the tail of the vector. This is your x-axis and this is the y-axis. So, what is there? R equal to A. Let R equal to A be the given vector. O is the tail and A is the tip. Draw x and y axis through the point O. Okay, x and y axis are drawn through the point O. You imagine that I cap is the unit vector in this direction, j cap in this direction. Okay? Let I cap and j cap be the unit vectors along x and y axis. So all these we have understood. Now, if we have drawn x and y axis to the point O, then what is the coordinate of the point O? Coordinate of O is 0, 0 and coordinate of A, anything, 2, 3, 5, 6, whatever. We take it as x, y. How can I write this? Because you have drawn coordinate axis now. So let AXY be the tip of the vector, tip of R. Now draw perpendicular on x-axis. This part is x, this part is y. this perpendicular be AM. Let AM perpendicular to x-axis. Then OM is what? This magnitude is x, and unit vector you know, just we have discussed, in this will be x into I cap. MA will be what? This is going to be y into G cap. Now this is a triangle. This is a triangle OMA. So in triangle OMA, we can write OA equal to OM plus MA. So this will be xi plus yg. So our vector is xi plus yg. So a vector in 2D has representation of this form. Obviously, when you are going to calculate the magnitude of this vector, mod r is going to be mod xi, length of the vector, this part x, this part y, this is 90 degree. By Pythagoras law, it will be x square plus y square. So this is representation of vector in 2 dimension. Any vector will be of this form, and its magnitude is under root x square plus y square. For example, if we have taken for r equal to 3i plus 4j, origin is the tail, 3, 4 is the tip, and mod r going to be what? Root over 3 square plus 4 square is equal to 5. Clear? Now we will represent in 3D. What happens in 3-dimensional coordinate system? You have to draw a vector and you have to complete a cuboid. Okay, I'm just taking the cuboid first. So this is a cuboid O, A, B and C. So you take these are rectangular axis. Along OA, the x-axis. This is your y-axis. This is your z-axis. This is the origin. You have taken the vector OP. Okay, better to say r equal to OP was a given vector. Let r equal to OP be the given vector. Then, like representation in 2D, what you have done? You have drawn coordinate axis through the tail of the vector. Okay? And then completed the diagram. Clear? Hope you have understood. You draw axis first if you are confused. OP is the given vector. You just take 3 coordinate axes from mutually perpendicular. X, this is your y-axis, and this is the z-axis. Okay? Then you have completed this parallelopiped. And from the idea of class 11 3-dimension geometry, you know, if this one is x, y and z, then OA, length of OA is x, OB is y and OC is z. Okay? And PM is the perpendicular here. You can join this also. Now this OP equal to R you want to represent in 3D. R equal to OP. In this triangle, in triangle OMP, R equal to OP, this is what? OM plus MP. OM is what? OM is what? OA plus AM. In triangle OAM, OM equal to OA plus AM. Okay. So R is going to be what? R is, this is unit vector I cap, here is J cap, and here it is K cap. So R equal to OA plus AM, because OM is OA plus AM and MP vector. Now OA vector is what? Along x-axis unit vector I cap, so xi. AM is what? Along z-axis z into k cap, and MP along y-axis y into j cap. xi, yj, zk. Okay, this is the vector R, and magnitude of R is what? Modulus of R why? Can you prove this? How the magnitude is under root x square plus y square plus z square? Because magnitude means length of OP. See, in this triangle, already I told you, triangle OPM, this angle is 90 degree. So in triangle OPM, OP square is OM square plus MP square. Now OM square is what? In triangle OAM, OM square is OA square plus AM square. So OP square is going to be what? OA square, AM square plus MP square. Just put it there. OA is x, AM is z, and MP is y. So R is under root So this is the magnitude of the vector. Clear? Now this vector can make angles with coordinate axis, OP vector. Yes, it can. What you are doing there, from P you are drawing perpendiculars. Where? If you want to draw perpendicular on axis, I will assume that all of you remember class 11 3-dimensional geometry. That perpendicular will go to A here on x-axis. It will go to B there on y-axis. It will go to Z there. I mean the point C over there on the Z axis. Is that clear? I am going to define the angles made by the vector with x, y and z axis. I will do it one by one. I have taken the same diagram here, just copied it little bit bigger. R equal to OP is the vector. that OP makes an angle alpha with x-axis, beta with y-axis and gamma with z-axis. And this point has coordinate x, y, z because you have taken x along x-axis way, y along y-axis OB, and this is z along z-axis. This is the concept you got in class 11 syllabus only. My aim is to find the value of L, which is cos alpha, M cos beta and N equal to cos gamma. What are those? Those are cosines of the angles made by the vector with x, y and z axis. These are called direction cosines. Let this is be L, M, N. These are cosine of the angles made by a vector with x, y and z axis. In this diagram, this angle 90. This is 90, isn't it? The angle it makes with x, y and z axis. Sorry, this is not gamma, this is 90, pi by 2. This angle is gamma. I drew it wrong. This is gamma. With z axis, the angle made by the vector OP, the diagram is obvious, that is gamma. So what is cos alpha here in this triangle OAP, cos alpha, this is the base and this is the hypotenuse. OP equal to mod r, length is root over x square plus y square plus z square, vector already we have written r equal to OP xi, yj and zk. So L cos alpha is what? X by under root and M cos beta is what? Y by under root x square, y square, z square, and this is z by under root. Hope you have understood, because length of this part r equal to OP is root over x square plus y square plus z square. Okay? And in this triangle OAP we have taken triangle OBP cos beta and triangle OCP we have written cosine of this angle, that base by hypotenuse everywhere. And R, a vector you can write without modulus, without arrow. I mean, if you simply write this is equal to R, that's fine. It will represent modulus of vector R. So can't I write L as x by R, because R is root over x square plus y square, M as y by R, N as z by R. So this implies x equal to LR, y equal to MR, z equal to NR. Okay? Now these three quantities x, y and z here, or LR, MR and NR, what is x, y, z? Tell me first. If you have taken R equal to xi, yj, zk, then x is taken along x axis. X stands for component of R along x axis, isn't it? Y stands for what? Component of R along y axis, and z is what? Component of R along Z axis. Now think of the vector that xyz. So P has the coordinate. Now P is going to be LR, MR, NR. Or these three quantities are components of vector xi, yz, zk. If you just find the ratio of these two, x is to this three, x, y, z, it is going to be LR, MR, NR. L is to M is to N. These three quantities LR, MR and NR will be referring as these three quantities. They are called LR, MR, NR. They are direction ratios of the vector. Element what? Direction cosines. So what I have seen there? That x is LR, y is MR, z is NR. Those direction ratios are proportional to direction cosines. LR, MR, NR, they are proportional to direction cosines. So DRs are proportional to DCs. Clear? Direction ratios are proportional to direction cosines. And what are direction ratios and direction cosines once more? In R equal to xi, yz, zk, x, y and z, I mean coefficients of I, j and k. I mean components of vector along x, y and z axis, they are called direction ratios. And x by r, y by r, z by r, they are called direction cosines. And drs are proportional to dc's. So just I repeat that part. For r equal to ai, bj, ck, what are drs of this vector? Drs of r are a, b and c. DCs of R are what? What? That is L. Cos alpha A by under root M cos beta B by N cos gamma C by root over sigma square. What sigma square stands for? Suddenly I am writing this, but all of you know it. We used it. So, hope you have understood the clear difference between direction ratios and direction cosines here. LMN are called direction cosines. ABC in the vector are called direction ratios. Now for this vector, if you take an example, r equal to 3i 4j plus 5k, these 3, 4 and 5, they are called drs. And this is a what? 3 by under root, that is going to be what? 3 by 25, I mean 5 root 2, root 50, and this is 4 by 5 root 2 and 5 by 5 root 2. So at the end of this session, I would like to say that I think you got the idea of a vector for class 12 mathematics. The concept of representation of a vector in 2D, 3D, and the difference between direction ratios and direction cosines. Okay, see you again in the next session.